Hello, welcome to the course on Hadoop development offered by DataRaj Academy. My name is Venu, and in today's session we will have a brief look at the history of Apache Hadoop. I hope you will all find this session interesting and informative. In today's session, we will try to understand how this amazing platform for the analysis of big data came into being. We will start by examining the conditions which led to the development of Apache Hadoop project. We get to hear about Apache Lucene and Apache Nutch quite often when we learn about Hadoop. We will try to understand the relation between them. Organizations like Google and Yahoo played major roles in the evolution of Hadoop. We will see how. This session is all about the evolution of Hadoop and the milestones set in the process. We will also see how different organizations like Facebook still continue to contribute to the growth of Hadoop. Hadoop is a funny name. We will look at the reasoning behind such a naming convention followed by the creators. In the next session, we will define Hadoop and start exploring all its features. So let's get started. Today, we are facing a situation of data explosion. Data is being generated from everything and from everywhere. People from all walks of life take videos and pictures on their smartphones and upload them. They text their friends. They update their Facebook status. They leave comments around. They also click on ads and do all sorts of things. Machines too are generating data at an exponential rate and keeping more and more data. Music, videos, photos, and lots of other stuff could be viewed as data. They are just digital files sitting on a hard disk. Files that are composed of just ones and zeros, that is digital data. These digital files, which contain machine understandable digital data, that is zeros and ones, have to be transformed for humans to understand. Hence, some kind of computation, which is basically digital signal processing, has to be performed to transform this digital data into some form which humans can understand. For this, we have many softwares and tools. For example, we use a VLC player to open .mp3 or .avi files. Similarly, we might use Microsoft Word to view a text document. Some sort of digital signal processing or computation is performed by these tools or softwares on the files and finally resulting in a user understandable format. This data explosion, that is exponential growth of data, first presented challenges to cutting-edge businesses such as Google, Yahoo, Microsoft, etc. Search engine-based organizations like Google and Yahoo had to go through terabytes and petabytes of data to figure out which websites were popular so as to rank them based on the relevant keywords. E-commerce organizations like Amazon wanted to find out customer preferences like what books were in demand and what kinds of ads appealed to people. Existing tools were becoming inadequate and have become obsolete, not useful anymore to process such large data sets. Hadoop was created by Doug Cutting, the creator of Apache Lucene, which is a widely used text search library. Hadoop has its origins in Apache Nutch, an open source web search engine which was itself a part of the Lucene project. Doug Cutting implemented all three projects, and each project was a logical consequence of the previous one. We will understand them briefly. First of all, one thing common for all these projects is Apache. What does Apache here mean? Does it have anything to do with the popular Apache server? Apache here refers to the Apache Software Foundation, ASF. ASF is an American non-profit corporation whose goal is to support and oversee Apache software projects, including the popular Apache HTTP server. The Apache Software Foundation is a decentralized open source community of developers. Software developers who want to contribute their work to the community for free can submit their software projects to Apache Software Foundation. The software ASF produce is distributed under the terms of the Apache license and is free and open source software. Apache HTTP server is one such free and open source software. Now what is Apache Lucene? Apache Lucene is a full-featured text indexing and searching library. It is suitable for any application that requires full text indexing and searching capability, be it internet search engine or a local single site searching. Desktop search, enterprise search, and many domain-specific search engines have been built using Lucene. Given a collection of text documents, a developer can easily add search capability using the Lucene engine. Now, what is Apache Nutch? Nutch is the most ambitious and logical extension of Apache Lucene project. In 2003, there was an attempt to build an open source web crawler and web search engine using Lucene as its core component. It was led by Doug Cutting and Mike Caffarella. Nutch is an open source web search engine based on Lucene. Nutch as a web search engine adds web specific functionality like it has parsers for HTML, a web crawler, a link graph database, and other extra components. Nutch is a project from the Apache Foundation as well. It basically extends Lucene to be a complete web search engine. Lucene formerly included a number of subprojects such as Mahout, Tika, and Nutch. These three are now independent top-level projects. Doug Cutting envisioned Nutch to be an open democratic alternative to the proprietary technologies in commercial offerings such as Google. Besides having added components like a crawler and a parser, a web search engine like Nutch differs from a basic document search engine like Lucene in terms of scale of volume of data. Building internet-scale search engines involve huge amounts of data and large numbers of machines to process it. In an attempt to build an open source web search engine, Doug and his team were having trouble in managing computations running on even a handful of computers. While Lucene is targeted at indexing millions of documents, Nutch should be able to handle billions of web pages without becoming exorbitantly expensive to operate. They needed something scalable because web had billions of pages. Nutch was intended to run on a distributed cluster of commodity hardware. The challenge for the Nutch team is to address scalability issues in software. Nutch needs a layer to handle distributed processing, redundancy, automatic failure, and load balancing. These challenges are by no means ordinary. They started designing something that could scale up to 4 to 5 machines, but they needed a more reliable system in place. Building a web search engine from scratch was a very ambitious goal. The software required to crawl and index websites is complex to write. It is also very challenging to run without a dedicated operations team, since there are so many software components involved. It's expensive too. Mike Caffarella and Doug Cutting estimated that a system supporting a 1 billion page index would cost around $500,000 in hardware with a monthly running cost of $30,000. However, they believed it was a worthy goal as it would open up and ultimately democratize search engine algorithms. With some progress, Nutch was started in 2002 and a working crawler and search system quickly emerged. However, its creators realized that their architecture wouldn't scale to billions of pages on the web. A much needed help came with the Google's publication of a paper in 2003 that described the architecture of Google's distributed file system called as GFS, which was being used in production at Google. Google even took the first step to publicize MapReduce. It is a system they had internally implemented to scale their data processing needs. Google claimed to use these two technologies for scaling its own search system. GFS or something like it would solve their storage needs for the very large files generated as part of the web crawl and indexing process. In particular, GFS would free up time being spent on administrative tasks such as managing storage nodes. Now, what is in these Google white papers published between 2003 and 2005? They have high-level design aspects of their internal implementation of Google file system, which caters to the web scale storage needs of Google. MapReduce, a programming style which addresses the processing needs of the huge volume of data stored in Google file system. And Bigtable, which is also another efficient storage mechanism. This system aroused a lot of interest because many other businesses were facing similar scaling challenges, and it wasn't feasible for everyone to reinvent their own proprietary tool. Doug Cutting saw an opportunity in this landmark event and wanted to develop an open source version of this MapReduce system. Doug Cutting identified the applicability of these techniques to Nutch, and his team started implementing the new framework under open source and ported Nutch to it. The new implementation immediately boosted the scalability of Nutch. It started to handle several 100 million web pages and could run on clusters of dozens of nodes. It started working but could make it work on 15-20 machines. In 2004, developers of Nutch set about writing an open source implementation of Google file system, and they called it Nutch Distributed File System, NDFS. Analogous to GFS was Nutch Distributed File System, but retained the name MapReduce for processing system. Google also released a paper on Bigtable, which was later implemented in open source as HBase, which is a columnar-based database. Early in 2005, the Nutch developers had a working MapReduce implementation in Nutch, and by the middle of that year, all the major Nutch algorithms have been ported or made to run using MapReduce and NDFS. NDFS and the MapReduce implementation in Nutch were applicable for not only search engines but also in many other use cases. And in February 2006, they were moved out of Nutch to form an independent subproject of Lucene called Hadoop. Yahoo was another major organization which was facing similar issues faced by Google and Nutch teams. Yahoo was working on building a graph of the known web. Creating and analyzing such a large graph requires a large number of computers running for many days. The infrastructure they were relying on at that time was not meeting their demands. In early 2005, the infrastructure of Yahoo needed to be redesigned to scale up to more nodes. They had successfully scaled from 20 to 600 nodes, but required a complete redesign to scale out further. Yahoo set up a small team and started designing and prototyping a new framework written in C++, modeled after GFS and MapReduce, to replace Yahoo's existing infrastructure. At the same time, Yahoo was watching Hadoop, which was part of Nutch, and its progress. To scale Hadoop further, Doug Cutting and his team were short of funding and resources. Yahoo approached Doug and showed interest in investing in the project and to improve Hadoop as an open source project. In January 2006, Yahoo hired Doug Cutting, and a month later, Yahoo decided to adopt Hadoop. This provided a dedicated team and the resources to turn Hadoop into a system that ran at web scale. The advantage for Yahoo of adopting Hadoop was that it was already working with a real application, that is Nutch, on 20 nodes. First thing they did was, they took the parts of Nutch that were a distributed computing platform and placed them in a separate project and named it as Hadoop. In other words, the Nutch project was divided. The web crawler portion remained as Nutch, and the distributed computing and processing portion became Hadoop. 2 years later, Hadoop achieved the status of an Apache top-level project. In January 2008, Hadoop was made its own top-level project at Apache, confirming its success and its diverse active community. By this time, Hadoop was being used by many other companies besides Yahoo, such as Last.fm, Facebook, and the New York Times. A well-publicized case that is worth mentioning is how the New York Times leveraged the Amazon's EC2 compute cloud for its processing needs. New York Times took advantage of the combination of Amazon's pay-by-hour model, which allowed the New York Times to access a large number of machines for a short period, and also Hadoop's easy-to-use parallel programming model. New York Times could crunch through 4 terabytes of scanned archives from the paper, converting them to PDFs for the web. And this whole process took less than 24 hours to run using 100 machines. Later in 2008, Yahoo announced that Hadoop running on a 10,000 plus core Linux cluster was its production system for indexing the web. This was demonstrated in February 2008 when Yahoo announced that its production search index was being generated by a 10,000 plus core Hadoop cluster. With the help of Yahoo, Hadoop soon grew into a technology that could truly scale to the web. In April 2008, Hadoop broke a world record to become the fastest system to sort an entire terabyte of data. Running on a 910 node cluster, Hadoop sorted 1 terabyte in 209 seconds, just under 3.5 minutes. In November of the same year, Google reported that its MapReduce implementation sorted 1 terabyte in 68 seconds. Then in 2009, it was announced that a team at Yahoo had used Hadoop to sort 1 terabyte in 62 seconds. The trend since then has been to sort even larger volumes of data at even faster rates. In the 2014 competition, a team from Databricks were joint winners of the Grey Sort benchmark. They used a 207 node Spark cluster to sort 100 terabytes of data in 1400 seconds, a rate of 4.27 terabytes per minute. So with time, Hadoop software has evolved to be more flexible and could manage bigger clusters. Bigger clusters meant more storage and processing powers, which could be utilized for various needs of the organizations. Hadoop's role as a general purpose storage and analysis platform for big data has been recognized by the industry, and this fact is reflected in the number of products that use or incorporate Hadoop in some way. Today, Hadoop is widely used in mainstream enterprises. Hadoop is a core part of the computing infrastructure for many web-based companies such as Twitter, Facebook, and LinkedIn. Many other traditional businesses such as media and telecom and even government are beginning to adopt this system. Commercial Hadoop support is available from large established enterprise vendors including EMC Square, IBM, Microsoft, and Oracle, as well as from specialist Hadoop companies such as Cloudera, Hortonworks, and Mapr. Two major open source projects came out on successful implementation of Google white papers, Apache Hadoop and Apache HBase. Hadoop started out as a subproject of Nutch, which in turn was a subproject of Apache Lucene. Hadoop was conceived to fix a scalability issue in this Nutch project. It sure took a couple of years to get it to work and scale to petabytes and to run on thousands of machines. But very soon, it was recognized as a reliable system. Later, a bunch of other projects, open source and proprietary, grew up around Hadoop. Hadoop became the kernel of an operating system for big data. In 2006, Hadoop was released by Yahoo, and today it is maintained and distributed by Apache Software Foundation. MapReduce is a complex idea, both conceptually and in its implementation. Hadoop users are challenged to learn all the knobs and levers for running Hadoop effectively. This tutorial will take you beyond the mechanics of running Hadoop and will help you to write meaningful programs using a MapReduce framework. There was a time when setting up, configuring, and writing programs to use Hadoop was an art. Things have certainly improved since then. There is more documentation, there are more examples, and there are thriving mailing lists to go to when you have questions. And yet, the biggest hurdle for newcomers is to understand what this technology is capable of, where it excels, and how to use it. That is what this tutorial tries to fulfill. The Apache Hadoop community has come a long way. In this time, the software has made great leaps in adoption, performance, reliability, scalability, and manageability. The number of things being built and run on the Hadoop platform has grown enormously. In fact, it's difficult for one person to keep track. To gain even wider adoption, we believe we need to make Hadoop more easier to use. This will involve writing more tools, integrating with even more systems, and writing new improved APIs. Many organizations in the pursuit of adopting Apache Hadoop have in turn contributed to the growth of the Hadoop ecosystem. Let us take an example of Facebook. In 2007, all of the data processing infrastructure of Facebook was built around a data warehouse built using a commercial RDBMS. The data that was being generated was growing very fast. The infrastructure at that time was so inadequate that some daily data processing jobs were taking more than a day to process. And the situation was just getting worse with every passing day. Facebook started exploring Hadoop to address their data processing needs. However, using Hadoop was not easy for end users, especially for the ones who were not familiar with MapReduce. End users had to write MapReduce programs for even simple tasks like getting raw counts or averages. Hadoop lacked the expressibility of popular query languages like SQL, and as a result, users ended up spending hours, if not days, to write programs for typical analysis. Facebook realized that in order to really empower the company to analyze this data more productively, they had to improve the query capabilities of Hadoop. Facebook envisioned to bring the familiar concepts of tables, columns, partitions, and a subset of SQL to the unstructured world of Hadoop, while still maintaining the extensibility and flexibility that Hadoop enjoyed. This way, data could be brought closer to users, and this is what inspired Facebook to build Hive. Hive was open sourced in 2008 and since then has been used and explored by a number of Hadoop users for their data processing needs. Hive is an open source petabyte scale data warehousing framework based on Hadoop that was developed by the data infrastructure team at Facebook. Similarly, many organizations are directly benefited with the adoption of Hadoop, and at the same time, organizations are innovating and developing new tools and frameworks which could supplement the capabilities of Hadoop. As a result of this, Hadoop ecosystem is becoming more vibrant and rich with new features and capabilities. You must be wondering, what is up with these names? Do they have any real meaning? What is the idea behind such a naming convention? The name Hadoop is neither an acronym nor does it have any meaning. It's a made-up name. Doug Cutting seems to have been inspired by his family when naming these software projects. He wanted a name that wasn't already an existing web domain and wasn't trademarked. So he tried various words that were in his life but not used by anybody else. Lucene is his wife's middle name. Nutch was used by his toddler son as the all-purpose word for meal. Hadoop was the name of a yellow stuffed elephant that his son played with. Short, relatively easy to spell and pronounce, meaningless, and not used elsewhere. Those were the naming criteria considered by Doug Cutting. Kids are pretty good at making up such words. Other projects in the Hadoop ecosystem also tend to have names that are unrelated to their function, often with an elephant or other animal theme. Pig, for example. With this brief understanding of the evolution of Hadoop, you can visit the official Hadoop website page to learn more about its interesting history. And for those curious few who want to check out and appreciate the design and architectural aspects in Google white papers, which are the original papers on the Google file system and MapReduce, it is worth going through the following papers. You can check out official pages of Google. You can find these links in the description of the video. And finally, we want to hear from you. As the viewer of this tutorial, you are our most important critic and commentator. We value your opinion and want to know what we are doing right, what we could do better, and any other words of wisdom you are willing to pass our way. We welcome your comments. Your feedback will be enormously helpful in improvising the final shape of this course. So please subscribe to Dataraj channel and contribute any questions, comments, or suggestions in the comment section below. Thank you.